everybody. We are going to look at some network concepts for Server+. So networking is what makes everything useful. If you only have a computer and it can't talk to other computers, then you can't share data. So networking is nice. So we need to be concerned about, we talk about cables and connectors. And are we typing slow? Come on. There we go. What do we need to know about cables and connectors? Wheel, hardware as well as software, miles of cables, wireless transmission. Let me check the locals website. Okay, storytelling. Cable connectors. So basically we're talking about copper and fiber. Now, mind you, in this particular, we're not talking about wireless transmissions, although it's probably going to be involved somehow, right? But cables and connectors, we're not talking about wireless, not in this context. So IP, Internet Protocol, on top of correctly, we know how to configure and troubleshoot TCP/IP. Usually referred to as IP, so we can call that TCP/IP. And then we could do IPv4, IPv6. We're going to learn stuff about. They got to be configured properly. Subnet mask, IP address, subnet mask, default gateway. Here, let's decapitalize all those. I don't know why. This seems like the right thing to do. What else do we have here? IP address, subnet mask, default gateway, DNS server. DNS servers are pretty cool. Because they can help resolve an IP address to a real name. So let's do this. IPv6 is 128-bit. And IPv4 is 32-bit. That's kind of important. So let's make notes of that. So IPv6 has a lot more unique IP addresses. This is a term we want to know. Quality of service. We're going to go down here. QoS. Actually, let's do it this way. Service. Okay, so now get up here. Page 2. All right. So we're still under IP. Oh, you know what? we need to back this up. Oops. Back that up. There. That's better. But we're still under IP right now, so let's get rid of all that. Oops. Okay. IPv4 is used everywhere on the internet. IPv6 is not so ubiquitous yet. I know a lot of people who just don't use IPv6 at all, or a lot of companies just don't. Only with a clear understanding of IP addressing and protocols in a multi-subnet environment can you properly support TCP/IP. Do you understand that? Okay. For example, a client workstation unable to connect to a server on a remote subnet. You might verify that name, resolution, and the default gateway router are configured correctly and reachable by the client. So, let's go back up here and let's ports and protocols, cables and bits. All right, application layer may contain protocols that allow direct interaction with users over the network, and they depend on the lower transport layer protocols such as UDP and TCP. Think of a web server listening for requests from client web browsers. HTTP is an application protocol that listens for client requests on TCP port 80. You can think of port listening as a channel that uniquely identifies a network service. So, port listening is like a channel that uniquely identifies a network service. Uniquely. How do you friggin' spell that? QU. Oh, jeez, what a pain in the ass. Identifies a network service. Okay. Port listening is like a channel that uniquely identifies a network service. That's pretty important. So if we're listening on a certain port, Hypertext Transfer Protocol listens on port 80. And other application protocols such as Simple Mail and Domain Name Service use different ports, 25, 23 respectively. Some network software will allow you to specify port number that is listens on. Know the application layer protocols and their port numbers. Okay. Okay, that makes sense. Let's do that. And scenario-based questions may indirectly test your knowledge in this area. Much more exhaustive would be presented in Chapter 5. Okay, so that's good for now. When we come back, we're going to talk about server operating systems. That's going to be our next. Here, let's take that out. Let's straighten this up just a little bit. There we go. Okay, so when we come back, we're going to jump into server operating systems, like up here. Kind of like that. Boom. Okay, and we'll talk about it when we come back. All right, see you then.